Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. Today I'll be presenting on Piaget and Bruner's theory in primary mathematics teaching under the course MTES3232, which is curriculum studies and learning theories in primary school mathematics. So without further ado, let's get to the presentation. Okay, so before we start, let us know about me first. So my name is Aqilah Amani Binti Badrul Hisham, and known as Amani, and I'm from Bahasa Melayu 2. Bahasa Melayu 2. My major is Bahasa Melayu and my minor is mathematics. And I'm the only one in major Bahasa Melayu take elective mathematics. So let's get started. So have you guys ever heard about John Piaget or Piaget? Not yet. So let me tell you guys about who is John Piaget, or known as Piaget. Okay, Piaget was a Swiss psychologist and one of the most influential figures in the study of child development. Development in what? Development in cognitive development, which focuses on how children think, learn, and make sense of the world as they grow. What makes his theory unique is the idea that children don't just know less than adults, but they actually think differently at a different stage of their development. Means the children know exactly the same, just like the adults, but they think differently on how things work. Okay? For example, at the primary school level, most children in Piaget theory calls the concrete operational stage, like from the age 7 to 11, if I'm not mistaken. Okay, at this stage, they can think logically, but their reasoning is still tied to things they can see and touch. Like, I give you an example. They know the pizza was delicious, but they don't know what made the pizza delicious. Right. They only think on what they can see only. Okay? That's why hands-on experiences like experiment or real-life problem solving are so crucial at this stage of age, so that they can think more deeper and make them more understanding better. In short, Piaget works remind us that teaching should be matched with how children think at each stage of growth. This means like the teachers need to suit or make the learning or teaching suitable for the student age. For example, if the student was only 8 years old, the teacher can teach them like they are 12 years old. Their cognitive are different level. So I will explain deeper on the next slide. So, John Piaget cognitive development theory. Okay, according to Piaget, children are not a passive learners. Instead, they actively construct their own understanding of the world by engaging with their environment. This means what learning happens best when children can explore. They can manipulate and interact with the object around them. For example, the mother teach them that the rock is hard, but they don't know what the meaning of hard. Okay, so when the mother give them the opportunity to touch the rock itself, they will know, oh, so this is what it calls as hard, like this. Okay, so here's the paper. So the mother's the important paper. So the mother say, oh, you can't don't touch the paper because it's important. Okay, or it will be crumpled. Okay, so the kids want to know about it. The kids want to know what is crumpled. So when the mother give them another type of paper or another kind of paper, and the kids will crumple them, oh, so they will know, that's what the mother means, like that. Okay. Piaget also explained that learning is a continuous process of assimilation and accommodation. Assimilation happens when children take in new experience and fit them into what they already know. Okay? For example, if a child knows how to count with their fingers, they may use the same method when they get to introduce to bigger numbers. Okay, so when we are kids, we have learned that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we know. We have 10 fingers and we count it to 10. Okay, we can count it to 10. So when the kids learned new bigger numbers, so they will count it by their fingers first if they haven't learned about how to calculate it or how to do it in the standard form. Okay, maybe they will repeat it, like here's the 10 and 11, 12, 13, 14, like that. So they will apply their own knowledge to the new one that they learn. Okay. On the other hand, accommodation occur when children need to adjust or modify their existing understanding to fit new information. For instance, when they realize that finger counting is not enough for larger number, they begin to use tools like number lines or whatever. Okay, so when they know, when they want to count and it was hard to use the finger, they will write. Maybe they will write 1, 2, 3, 4, 5 until 10, and they will repeat it again and again. So it makes it easier for them. They will learn a new technique, or they will figure out the problem solving itself. For mathematics teaching, this theory suggests that teachers should not just deliver abstract formula directly, abstract by not writing or given real things object. Instead, they should provide activities and experiences that allow the student to experiment, discover, and adapt their understanding step by step. Let us get to the deeper level of John Piaget theory. Okay, children progress to the distinct stage, which is 4 stages in John Piaget theory. First, sensory, pre-operational, concrete, and formal operational. Okay, for sensory, it's from the age of 0 to 2 years old. At this age, they will touch, or they will use their sense to know things. Like they will touch, they will grab, they will use their muscle a lot to train or to make their muscles adapt, like that. Okay, at the stage of pre-operational, from the age 2 to 7 years old, they will discover a lot. Like at this stage, they will make more experiment by themselves. Like they will figure things out and they will play with it. Okay, I will explain it on the next slide. So at the age of concrete stage, it was 7 to 11 years old, which in primary school. At this stage of age, they need to know something by looking or touching. That will make them easier to understand. Okay, when they can, as we know, we can understand better if we use a lot of our senses. Like when we study, we use eye, we use our ear, and at this concrete level, they will touch, they will see. So that make them easier to understand of what they learn. And the last one are the operational stages, from the age of 12 years old. Okay, so according to Piaget, children don't develop their thinking skills all at once. Instead, they progress to 4 distinct stages of cognitive development. Okay, the first is the sensory motor stage, from birth to 2 years old, where learning happens through senses and movement. Next is the pre-operational stage, roughly between age 2 and 7, when children begin to use language and imagination, but their thinking skill is still very egocentric. Okay, like when they use they trust their imagination more. Okay, like when they believe that their mother will angry at them when they don't eat. They believe like that, but they don't think the disadvantage, the cons, or the factors of why the mother get angry. They don't think like the mother was worried if they don't eat, then they will get sick. No, they don't think like that. Okay, so then comes to the concrete operational stage, from around 7 to 11 years old, where children start thinking more logically but still rely heavily on concrete hands-on experience. Just like what I said before, they want to know something, but they need to see it first. They need to, I do it like this, so it happened like that. So they believe on things that happen in front of their eyes. Yeah. Finally, the formal operational stage begins in adolescence, 12 years old and above. At this stage, children and teenagers can think abstractly, reason logically, and solve more complex problems. Like us now, we are on operational stage, formal operational stage. Like we can think of, oh, so this is why things happen. So if I don't do it like this, then it will become like that. So we know the pros and the cons of what we did. Okay, so Piaget showed us that children things evolves step by step. The development will get slowly by the age, and each stage builds the foundation for the next stage of development. Okay, so now we want to focus on 7 to 11 years old kids or age. So for primary school, the concrete operational stage is most relevant, where children begin to think logically about concrete events. So I will show you the situation and example of how students think and what teachers should do to make them understand of why this happened, the reason behind things. The example next. Okay, so the topic that I choose that I think relevant for Piaget theory is fraction, year 4. Since in this topic, the student will learn from the small number of fraction to the bigger number. So they will learn on step by step of how fraction happens. Okay, so the first one was use real object or material. So here's when the teachers need to play such a big role. Like the teacher, when get into the class, the teacher need to give the example for the student, like for a real things or object. Okay, so for this topic, for fraction, as we know, pizza we eat when we have cut it, right? So so teacher might print the pizzas on a piece of paper and give it to all the students. So the students are free to fold it to half, to quarters or thirds. So when they fold it, they can see it. So here's, imagine that this is the pizza, and so when they fold it to half, okay, so they will see, oh, it become smaller. Okay, when they fold it to quarter, then it become much more smaller. So they will see the differences of one or whole size of pizza, and when they fold it, it will become smaller. Okay, so the next point is experiential learning. By applying Piaget theory, student can compare pieces by stacking or overlaying to show equivalence. Like maybe the teacher gave them 2 pieces of pizza's paper, then they can compare it. Like they can compare it, for example, so here's the main page of pizza, and then when they fold it to half, and it will become this big only, this size. Okay, so they will compare it with the other paper that the teacher gave. The other paper. Okay, so they will overlaying like this. So they will see, oh, when I fold it to half, it will be this small, or when I fold it to quarter, it will become much more smaller from the whole size at first. Okay, so they can see and compare the pieces and understand that the more people share, the smaller the fraction piece. Like, yeah, like that. Okay, so third, active participation. Students are asked to manipulate fraction strips. Second one, thinking fraction size depends on shape rather than area. Okay, like okay, when we do this hands-on material or something that they can see, they will ask a lot. So it will make the class active participation. They will be more interested in learning the topic or the chapter. Okay, so thinking fraction size depends on the shape rather than area, because they will think critically on how is this happen, on how of that happen. Okay, the last one, increase cognitive development thinking. Okay, so here's the pros of applying Piaget theory of cognitive development in education. Firstly, Piaget theory is a student-centered, as we know. This means that the focus is not just on what the teacher delivers, but rather on how the children learns. According to Piaget, children learn best when teaching is matched with their developmental stage. In other words, teachers should not expect a 7-year-old kids to think like a 12 years old or a teenager because their cognitive structures are still growing. For example, teachers need to teach 7 years old kids like they don't know anything. Teacher needs to teach them just like from the basic one because they don't know or they don't think the same as we adult. Okay. So, by applying Piaget theory, teachers can respect the natural stages of development, making learning more impactful for the student. Because as the teacher make the apply the teaching skills suitable for the student age, they will understand it better and find the class more fun, and it will help them to understand better in class. Okay. Secondly, the theory allows teachers to design the age-appropriate activities that match student cognitive abilities. Okay, so for example, younger children who are in the concrete operational stage from the age 7 to 11 learn better when they manipulate real object rather than working with abstract concrete. Okay, meanwhile, older student like 12 years old and above, student in the formal operational stage can handle abstract reasoning and hypothetical thinking. This helps prevent frustration and ensure that students engage at a level they can actually understand. For example, if the teacher teach the adolescents just exactly the same like the 7 to 11 years old kids, it will make them boring or find it funny because, oh, I know this, but why the teacher do it like this? Oh, they will disrespect the teacher too, and it will make the class not impactful as we want. Okay. Thirdly, Piaget theory encourage critical thinking. Because of why? Since Piaget emphasized the importance of reasoning, students are encouraged to justify their answers and explain their thinking process. Okay. For example, instead of simply memorizing that 2 plus 2 instead of simply memorizing that 2 plus 2 equals to 4, a child should be guided to understand why it equals to 4, or the other way to understand, like, okay, 1 plus 2 plus 1 plus 1 equals to 4. Okay, so they need to know why things happen instead of memorizing it like the traditional style of teaching. Okay. Hence, if they understand, they can easily answer the question even if the question is different. This way, students do not just memorize information but learn how to apply. They learn how to apply the things itself and problem-solving skills, which are useful beyond the classroom. So, let's move to the next figure. So, who is Bruner? So, Bruner was an American psychologist and educational theorist. He was a very bright person and a very well-known person in this education field. He's best known for his work on cognitive development and how children learn through discovery and experiences. His theory greatly influenced modern teaching methods that emphasize active learning and problem solving. Okay? According to Bruner, students don't just learn by listening, but they actually learn by experimenting, exploring, and solving problems on their own. Okay? Have you guys ever read or learn? We need to use most or all of our senses if we want to get the input as much as we want. Okay, if we use only one sensory, then the things or the input that we get only 12%, something like that. Okay, so in this theory, he said that we need to use experimentation. When we use experimentation, we already use 3 to 4 senses. Okay, one of his key ideas is that learning can take place through 3 different methods: inactive, which is learning through action; iconic, learning through image; and visual aids, which is learning through language and abstract thinking. Okay, unlike Piaget, Bruner argued that these modes are not tied strictly to age or sequence. Instead, a child can use all 3 modes at the same time, depending on the task given. Okay, this means that teachers have the flexibility to adjust the curriculum according to student abilities and make it more practical, visual, or more abstract, depending on what works best for them. Okay, pembelajaran terbeza. So this is what Bruner take about. Okay, so Bruner's theory of learning and how it can be applied in the classroom. Firstly, Bruner's belief that instead of just listening to the information, students should be actively involved in experimentation, exploration, and solving problem. Student itself need to involve in the teaching method. Student can't just see or we do it like teacher-centered learning. Okay, instead of we need to use student-centered learning. Okay, for example, in a science class, rather than only reading about magnets, students should test them or make the experiment and see the result themselves. If solve, it will if the same things, and we make it close, and it will menolak. Okay, so they can see why this happened, or they will memorize it more if they do the experiment. Secondly, Bruner explained that learning can happen through 3 modes, just like I said before. Importantly, Bruner said that these modes can happen at the same time, not strictly in a fixed order or by age. This means that even older students can still benefit from pictures and hands-on activity when learning abstract ideas. Yeah, because as we know, each student have different kind of development, thinking or understanding. So when the slow kids can learn something by pictures or hands-on material, it make them easier. It's easier for them to understand the topic that the teacher teach, especially in mathematics, science. Yeah, in that subject, student actually need to see it, the things itself. As the same like me, I'm a very slow student in my high school, but I take advanced. So what the teacher do for me is they will draw something or make it easier for me to understand. So this is how function works. So this is how the graph will be when we connect the dots and something. Lastly, Bruner theory shows that teachers can adjust the curriculum to suit student abilities. This doesn't mean that teacher can change the curriculum, but this shows that how teacher can make the education suitable for all. Okay, since learning is not tied to rigid to developmental stage, teacher can introduce complex idea at an early stage as long as they are presented in simple way. Yeah, student can understand better if the things are simple. Just like what I said before, for example, in the topic of account, I take account, and when I don't understand debit and credit and so on, I don't understand how was debit or credit. Why that thing happen like that and like this, and the teacher explain it to me by give the model itself, or hand in printed material to me, so that I can understand it better. Okay, over time, these ideas can be revisited at higher levels of complexity. Okay, so when the teacher gives the materials, hands-on material, then the teacher can repeat it, the same topic or the same basic at the different level of stage, so that the student can memorize it. This flexibility makes learning more inclusive and allow every student to progress at their own pace. So, for conclusion, Bruner's theory highlight this important strength: learning by doing, learning through multiple modes, and a flexible curriculum by teachers. Okay, so now let us see how Bruner's theory can be applied in the topic of money in year 2. Okay, so we begin with the inactive stage, which is learning through action. Okay, at this stage, students handle real coins and notes, such as 1 ringgit, 50 cents, or 20 cents. For example, the teacher might give students 250 cents each of them and ask them to combine them. Combine 250 cents, okay, by physically holding and touch the coins by themselves. Students can see and feel that 250 cent coins equal RM 1 ringgit, because 50 cents plus 50 cents equals to 1 ringgit, right? So they can, like this. This is powerful because children at this age often learn best through concrete experiences. Okay, they are not just told the value, they discover it themselves through direct manipulation. They can see by themselves, like 50 cent become 1 ringgit, 1 ringgit plus 1 ringgit become 2 ringgit, like that, instead of just listening and imagining. Okay, in this way, money becomes something real, not just a number on the board. Okay, so the next one is iconic stage, where learning take places through image and visual. Okay, iconic, just remember image and visual representation. After handling real coins, okay, the teacher can show students pictures or drawings of coins and notes. For example, so here's the whiteboard. Teacher draw the 1 ringgit RM1. Okay, so they can imagine, so here's the 1 ringgit. Teacher doesn't need to bring the money, the real money itself in class. Okay, student may be asked to be in a group, match, or even cut and paste picture to demonstrate the value. Okay, so the teacher might ask the student to draw the money. So the student can draw 2 circles to show that is 20 cents or 50 cents. Okay, for instance, like that. Another example is showing that 2 drawings of 5 ringgits, 2 5 ringgits is equal to 10 ringgits. Okay, the advantage here is that students are no longer limited to the physical coins. Okay, so they don't need to see the actual or the real thing. They can imagine it by, if the teacher draw RM 1 ringgit, so here is 1 ringgit. Okay, so the teacher doesn't need to bring the real thing itself in class. Okay, this stage help bridge the gap between real life handling and abstract reasoning. So here's the mid level, where student can think logically or can imagine the real thing and apply it in the class. Okay, finally, we move to the symbolic stage, where students use numbers and symbols like ringgit and cents without needing real coins or picture. Okay, at this stage, the teacher introduce written problems. For example, okay class, 2 ringgit 50 cents plus 2 ringgit equals to how much, like that. So the student just need to think and imagine it in their by themselves only. Okay, they don't need to, the teacher doesn't need to write, draw, or bring the notes or coins. Okay, they just need to imagine it by themselves. Okay, 2 ringgit 50 cents plus 2 ringgits. Okay, so they calculate it in their brain. Okay, so it will be 4 ringgit and 50 cents. Okay, here students are applying what they learn from action and image to solve problem using mathematical operation. This stage is crucial because it prepares them for real life financial decision. Okay, where money is often represented symbolically, such as in receipt, bills, and bank account. Here the student doesn't need, if we talk in terms of bank account, so students just need to know that, I have 100 ringgit, so here's the amount of money that I have. So they doesn't need to see or feel it by themselves. Okay, Bruner's theory is powerful in this topic because it shows a clear progression of learning. Students move from concrete experiences to visual understanding and finally abstract problem solving. Okay, so we can see that student understanding are moving or progressing slowly, but they will get it. Okay, from concrete to abstract itself, you can see. Okay, for example, after students succeed with real coins, the teacher shift them to pictures. Okay, and finally, symbolic problem solving. This gradually progression ensure that students are not left behind, and that every learner can build a strong conceptual understanding of money. Okay, in conclusion, applying Bruner's theory to the topic of money in year 2 not only helps students to count and calculate in real life, but also develop their problem solving, reasoning, and financial literacy. Okay, so here's the importance of applying Bruner's theory in teaching and learning. Okay, the first key idea is activating prior knowledge. According to Bruner, learning builds on what students already know. Okay, so before introducing a new lesson, teachers should try to diagnose student prior knowledge. Like, this can be done by asking short questions or giving a quick task related to the topic that we want to teach, or reviewing what they have learned previously. For example, before teaching fraction, the teacher might ask students simply question about dividing a pizza or sharing sweets equally. Or like, Adam, you have 4 sweets. Then how much can you give to Anis if you both want the sweets equally? Okay, 4 divided by 2 equals to 2. So the student already know the basic thing. So when the student already know it, so the teacher can proceed to the different stage of teaching. Okay, it helps students link new knowledge with their existing mental structures, existing knowledge, making learning more meaningful and easier to remember. Okay, so the second key idea is scaffolding and guided discovery. Bruner believed that students should be active learners, but teachers play an important role in supporting them. Okay, in scaffolding, the teacher gives prompts, hint, or work example to guide student thinking. For example, in solving a math problem, the teacher might first show the step, or the teacher might show the formula first, and so on. Then provide a partially worked example, and finally let students try it on their own. Over time, the teacher gradually withdraws help student, and the student become more confident and independent to do the worksheet or the exercise itself. This process encourages learners or the student to discover knowledge themselves. Oh, how should I do this function question? Oh, so here's the step. First, I need to solve this first, like that. Okay. So the third important concept is the spiral curriculum. The spiral, just like what Sir Zaimi teach us in class, the image like that. Okay, Bruner suggested that big ideas in a subject should be revisited again. Yeah, we need to relearn or recall the thing that we have learned at a different level of complexity. For example, in science, students may first learn about plants by naming parts of a flower in primary school. Oh, so here's the leaf, here's the flower, here's the Later, in secondary school, they revisit the same topic but at a deeper level, such as studying photosynthesis, or the cell function, or the name of the cell in the leaf. Okay, this approach allow knowledge to spiral upwards, linking new learning to earlier representation. Okay, linking the knowledge that they already have with the new knowledge. In this way, students continuously strengthen and expand their understanding. Okay, so both of these theory, when we apply in class, where we can learn actively, so student will be actively, and there will be two ways communication of the teachers and the student itself. Okay, then the last one, it will create a better classroom, happy, active, meaningful classroom, and make a student-centered learning, just like what KPM and Falsafah Pendidikan Negara want. So that's all from me, and thank you.